this concept, minor of an element and cofactor of an element. Yeah, dear students. So first, let us discuss what is the meaning of minor of an element. The minor of an element, Aij meaning we already done. We already discussed about Aij. Aij means ith row jth column element. Aij means. See, Aij, the minor of an element. Minor of an element. Minor of an element. I will give example also, dear students. Minor of an element. Aij of the determinant obtained by deleting ith row and jth column. Ith row and jth column in which the element Aij lies. It is denoted by Mij, that means minor of that element. It is denoted by Mij. See how we are going to, we'll take a 3 by 3 matrix, dear students. Here example I am taking. This is capital A, A11, A12, A13, A21, A22, A23, A31, A32, A33. I am taking example of 3 by 3 matrix. Here I will consider one matrix. For all determinants only we can consider. Suppose for example 1, 2, 3, 4, 5, 6, general example I am taking, 7, 8, 9. So this is 3 by 3 matrix now. Find minor of element 3. This is example. See how we are going to do that. Find minor of element 3. See, based on the definition, what we discuss the definition. Minor of an element Aij of the determinant. See, 3. In which place this 3 element will be there? A13. So, this is first row, third column element. This we are going to eliminate. See, this position is A3 is equal to A13 element, dear students. This is I, this is J. See here, ith row, jth column. That means first row. First row means this one. We are deleting. Next, third column. Third column means this one. We are deleting third row and first row, third column, and determinant obtained by the determinant. What is the determinant? The rest of the determinant is this one, So it is denoted by mij, M13 is equal to M13 is equal to determinant of 4, 5, 7, 8. So we know that how to calculate 2 by 2 determinant. 4 into 8, 32, minus 7 into 5, 35. So which is equal to minus 3. Therefore, the minor of an element of 3 is equal to minus 3. This is the way we can calculate, dear students. I hope you understand the definition. Now we will move to concept of cofactor of the element. See, cofactor of the element, cofactor of an element Aij is denoted by capital Aij and is defined as Aij is equal to minus 1 whole power I plus j multiplied with the minor of Aij. That means Mij, dear students. So for the same matrix, for the above matrix, example, for the above matrix, I am taking find the cofactor of an element. Suppose, for example, cofactor of we will take it 7 element. Cofactor of element 7. So first, what we have to do is the element 7 equal to element. This is what is the position of this element in this matrix, in this determinant. 7 is third row, first column element. So it can be written as A31. Am I right, dear students? This is I, this is J. Third row, first column element. So I value 3, J value 1. First, what we have to calculate? We have to calculate the minor of this element. Minor of A31 is equal to, it can be denoted by M31 is equal to, M31 denoted by, see for this same, 7 is the position, no? So eliminating this row and this column. So if you want, I will write it here, dear students. For the same, this is the determinant. So same example, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I want a 7 element minor. So eliminating this row and this column, the rest of the determinant we are writing. So what are the elements? 2, 3, 5, 6. I hope you understand. I is equal to 3, j is equal to 1. So 2 into 6, 12, minus 5 into 3 is 15. That is equal to minus 3. So M31 we got it as minus 3. Therefore cofactor, what is the definition of cofactor? Cofactor of A31 is equal to capital A31 equal to minus 1 whole power 3 plus 1 Ij and multiplying by M31. So minus 1 whole power 4, M31 value minus 3. So which is equal to minus 1 whole power, even number of times plus will come. 1 into minus 3, which is equal to minus 3. I hope you understand this example, dear students. This is about cofactor of an element. Now we will enter into the exercise 4C. We already kept that. Before discussing the exercise, I want to give some concept. That is the reason I have given. Let us discuss the first question in this. We already done the first bit in 4B exercise. In 4C, second bit, we are going to start directly. So what is the first question is, write minus and cofactors, and cofactors of the elements of determinant of 2 minus 4 0 3. So let us discuss one by one, dear students. So what is the criteria to, so first the given determinant, so 2 minus 4 0 3. So first we have to take their positions A11, A12, A21, A22. Okay. Later we will calculate all M11, M12, M12, M13, M21, M22. So we know that, see, to get M11 means this is the position, 2 element. For 2, you have to eliminate this row and this column, the remaining is 3. After eliminating, so you will get only mod 3, dear students. So which is equal to 3. Next, M12 means this one. So eliminating of this row and this column, we have 0. So determinant 0. Next, eliminating of this row and this column, remaining is mod minus 4 equal to minus 4. Don't think that it is mod, this is the determinant. Don't consider as mod, dear student. This is determinant. In determinant, whatever the value you have, that only you write it. Determinant is the symbol for only this. It not modulus. Next, eliminating of M22. This is the element. You have to eliminate this row and this column, remaining is 2. So determinant of 2, that is equal to 2. Next, these are what? Minus of given det. Next, cofactors of given det. Cofactors of given det. Determinant. See how cofactors are denoted by A11 multiplied by minus 1 whole power 1 plus 1 with M11. So minus 1 whole power 1 plus 1, that is plus 1, into M11 value 3, that is equal to 3. Next, A12 minus 1 whole power 1 plus 2 into M12. So this is minus 1 into 0, which is equal to 0. Next, A21 minus 1 whole power 2 plus 1 into M21. Minus 1 whole power 2 plus 1 is minus 1 into minus 4. So which is equal to plus 4. Next, A22. This is defined as minus 1 whole power 2 plus 2 into M22. That is equal to minus 1 whole power even power is plus 1 into M22 value is 2. That is equal to 2. So these are the cofactors of 2 by 2 matrix determinant. These are the minors of that element. So similarly, we can find the cofactors of the other end. So question number 2, write minus and cofactors of the elements of det of A, C, B, D. See how we are going to do that. So similar way we can go. First, given determinant. So given determinant A, C, B, D. So let us consider the elements as A11, A12, first row, first column, first row, second column, A21, first, second row, first column, second row, second column. So first calculate the values of minus one by one, minus of given debt, minus of given debt. So first calculating M11. M11 defined as eliminating first row, first column, A22 is that. So debt A22. What is that debt A22 value? D. Determinant of D, that is equal to D. Okay, dear students, let us consider M12. Eliminating this row and this column, A21 will be there. That is equal to A21. So whatever the value A21 place is there, that only write it. Mod B, the debt B. We cannot say mod. Debt B, that is equal to B. Next M21, second row, first column, second row, first column. So debt of A12. What is A12 position? A12 position is C. So debt C is equal to C. Next M22, second row, second column element. So if you eliminate this row and this column, A11 will be remaining. Debt of A11, A11. So A11 is debt A. Debt A is equal to A. Okay, dear students. Similarly, cofactors of given debt or given determinant. So cofactors are denoted by A11 minus 1 whole power 1 plus 1 into M11. So minus 1 whole power 1 plus 1 is plus 1. M11 value is D, that is equal to D. A12. So A12 is equal to minus 1 whole power 1 plus 2 into M12. So minus 1 into M12 value is B, that is equal to minus B. Next, A21 minus 1 whole power 2 plus 1 into M21. So minus 1 whole power 2 plus 1 is 3. Minus 1 into M21. M21 value is B. M21 value is C, which is equal to minus C. So A22 minus 1 whole power 2 plus 2. M22. So plus 1 into M22 value is A, that is equal to A. Okay, dear students, I hope you understand. These are the cofactors of 2 by 2 matrices. Now, using cofactors of elements of second row, evaluate determinant. See, the question is crystal clear. Question number 3. Using cofactors of elements of second row, evaluate delta equal to 5, 3, 8, 2, 0, 1, 1, 2, 3. So dear students, in how to proceed, they are asking to find cofactors of elements of second row. So I want to consider second row. What is second row elements? A21 is equal to 2. A22 element is 0. A23 element is 1. Only for these elements you have to calculate minors as well as cofactors. Then only you can find out delta value, discriminant. Determinant. So first calculate M21, for this M21 equal to eliminating of this row, second row and first column. So if you eliminate second row, first column, the remaining is 3823 will come, dear students. Just I will, with pencil we can do, no need. A21 element is 2, no? So this row and this column, if we eliminate, 3823 determinant will be formed. 3823. So which is equal to 9 minus 16, which is equal to minus 7. Next, M22. So eliminating of second row, second column. Second row, second column, if we eliminate, 5813. So 5 3s are 15 minus 8 1s are 8. This is plus 7 will come. Next, M23. So second row, third column. Second row, third column if you eliminate. So 201 and 813 eliminating. 5312 is will be remaining determinant. 5312. That is equal to 10 minus 3, which is equal to 7. Are you able to understand, students? After that, for respective values, calculate A11, A21, A22 and A23. So A21 minus 1 whole power 2 plus 1 into M21. So this is minus 1 whole power 2 plus 1 means minus 1 into M21 is minus 7, that is equal to 7. Next, minus 1 whole power 2 plus 2 M22, that is equal to 1 into M22 value is 7, therefore it is equal to 7. That is equal to, next, A23 minus 1 whole power 2 plus 3 M23, that is equal to minus 1 into minus 7, that is equal to plus 7. Therefore delta is equal to cofactors of elements of second row. Second row means this one. So what I want to write it is A21 into capital A21, this is the definition of determinant, plus A22 into capital A22 plus A23 into capital A23. So we know the values. So A21 value is 2 into A21 value is 7 plus A22 value is 0 into A22 capital A22 value is 7 plus A23. This value is 1 into capital A23 is 7. So 14 plus 0 plus 7, which is equal to 21. Therefore, determinant of given determinant by using cofactors of elements of second row is equal to, we got it as 21. Okay, dear students, I hope you understand. We'll move on to other question. Somewhere else we did so minus plus it was changed maybe. Your 10 minus 3 7, your 15 minus 8 is okay. 9 minus 16 minus 7. Yeah, while calculating here, plus minus plus will come. No, this is the A21. This is the element A21 means 2 plus 1. So cofactors is minus 1 whole power 2 plus 1 is minus. Minus into minus plus. Minus 1 whole power. This is plus 15. Is plus 7. Minus, yeah, this is plus 7, no, I'm very sorry. This is minus 7. This is minus 7. This is minus 7. So, 14 minus 7, which is equal to 7. I'm very sorry, dear students. So, your answer is delta is equal to 7. I'm very sorry. Here I forgot. That minus C total, if one minus will change your total answer, please be aware of this. So your answer delta is 7. Every step we completed We'll move to question number 4. Using cofactors, using cofactors of element, cofactors of elements of cofactors of elements of third column, evaluate delta equal to, delta means determinant, 1x yz, 1y xz or zx, 1z xy. See, first, what we have to do is you need to write the elements of third column. What is third column elements? So elements you write it first. A11, A12, A13, A21, A22, A23, A31, A32, A33. In this third column they mentioned. What are third column elements? A13, that is equal to YZ. A23, that is equal to ZX. A33, that is equal to XY. So for these elements, respective minus calculate. M13 is equal to, so M13 means this one, M13. This is M13, no? So eliminating of this row and this column. So what result will get it? 1y, 1z, that is equal to z minus y. Okay, dear students. Similarly, step by step. A23. So for this M23 is equal to second row, third column. Second row, third column is second row, third column, eliminating 1x, 1z. 1x, 1z. Determinant of this one, 1 into z minus 1 into x, z minus x. A33. So eliminating of this row and this column. So M33 is equal to determinant of 1x, 1y, that is equal to y minus x. After finding these minus, after eliminating of these minus, next cofactors calculate, no? So A13 is equal to minus 1 whole power 1 plus 3 into M13. So which is equal to minus 1 whole power 1 plus 3. Minus 1 whole power 1 plus 3 means 4. Plus 4 means it is positive. So z minus y as it is. Next, A23 is equal to minus 1 whole power 2 plus 3 M23. So which is equal to minus M23 value z minus x. Next, A33 minus 1 whole power 3 plus 3 into M33. So this is positive. Minus 1 whole power 6 means plus 1. So next, y minus x. Later determinant. Therefore, delta equal to A13 into capital A13. Small a13 into capital A13 plus A23 into capital A23 plus A33 into capital A33. So which is equal to A13 means YZ into A13 xz minus y plus A23 means plus into here minus is there, no? So minus direct I'm writing zx into z minus x. So yeah, also dear students, tell me, A33 is xy into y minus x. So which is equal to yz square minus y square z minus z square x plus x square z plus xy square minus x square y. After that, so is there any yz already there? No. Yz. From here and here, if we calculate from yeah, can you teach easy things? I am a grade 5. Guess what? I am joking. Yeah, I will discuss later, dear students. Why? Because seriously, class is going on. I hope you understand. So, which is equal to from these two, y if we take out common, z square minus x square. Okay, no problem, dear students. From these two, z square where it will be? Next, from this and from this, z if we take out common from these two, x square minus y square. Next, from these two, you take common x, y square minus z square. Yes, yes, I am from India, dear students. Yeah. Exactly what do you want? Why? Because I didn't have time. This is already odd time I am explaining. Some students are waiting for the session. That's why you can chat later, dear students. Yeah, from this x square, where did I take common x square from this? Here x square term is there. Even here also x square term is there. From this, I am taking common x square. I kept the dot marks. X square, if we take out common from this, z minus y will be available. Okay. Next, what we have to do is uh, from here, from here, plus x into from these two yz anyway take common. From here, x into y minus z into y plus z. Next, from these two, yz if we take out common, z minus y will be there. So x square into z minus y minus x into here z minus y into y plus z plus yz into z minus y. Here little confusion is there. Slowly you can understand. From every term z minus y take common, x square minus x into y plus z plus yz. So z minus y into x square minus xy minus xz plus yz. So z minus y what I'm taking is now x I'm taking common from these two. X into x minus z minus y I'm taking common from this x minus z will be there. So which is equal to z minus y into x minus z take common into x minus y. If we write in the order x minus y into y minus z, here I'm taking common minus y minus z. Even here also take common minus z minus x. Minus into minus is plus. Therefore, x minus y into y minus z into z minus x. Little here you can take some precautions to practice this, dear students. Therefore, the det of the given matrix by using third column. Third column. This is the way we can do it. Okay. Next, find minus and cofactors of the elements of the determinant. More two questions are there. We'll finish it in this session. Therefore, third bit we are entering into the third question. Third bit. So third bit. Question number 1. Find minus. Find. Are you getting all of you? Find minus and find minus and cofactors of the elements of the determinant, the elements of the determinant. The determinant is 1 0 0 0 1 0 0 0 1. Okay, dear students, this is the question. For us, this is the question. For this, we need to describe that. First, what we have to do, this given determinant, like this, you make a rough work. A11, A12, A13, A21, A22, A23, A31, A32, A33. So for every element, minor as well as cofactor, you can calculate. See in what way we will proceed. One by one, I will explain, dear students. So first, cofactors of, first the elements of, directly don't go for cofactors, minus. First minus I am calculating this side and the cofactors, this will be this side. See how we are going to do that. So A11, first element, A11 element is 1. For that, M11 is equal to, that means first row, first column eliminating. So the determinant of this one, 1 0 0 1. So 1 minus 0, that is equal to 1. Next, the element A12. A12 is 0. So M12 equal to eliminating of this row and this column 0 0 0 1. So which is equal to ultimately 0. 0 minus 0. Next, A13, 3 elements. A13 element is also 0. M13 is equal to, that means eliminating of first row and third column. First row, third column, if you eliminate 0, 1, 0, 0. 0, 1, 0, 0. So 0 minus 0. Next, A21. A21 value 0. So M21 is equal to eliminating of second row and first column. Second row, first column. So 0, 0, 0, 1. 0, 0, 0, 1. So 0 anyway. Next, A22. A22 element is 1. M22 equal to. So M22 means eliminating of second row, second column. 1, 0, 0, 1. That is equal to 1. Next, A23. A23 is 0. M23 eliminating of second row, third column. 1, 0, 0, 0 will come. 1, 0, 0, 0. Anyway, if you find out the determinant of this 2 by 2 matrix, you will get 0. Next, A31, third row, first column, that is 0. So, M31 equal to eliminating of third row, first column. Third row, first column eliminating 0, 0, 1, 0. 0, 0, 1, 0. So, even this is also 0. A32. Eliminating of second row, so third row for second column, M32. So, which is equal to third row, second column, eliminating 1, 0, 0, 0. 1, 0, 0, 0. That is equal to 0. A33. That is equal to 1. M33. Eliminating of third row, third column. Third row, third column, if you eliminate 1, 0, 0, 1 will come. That is equal to 1. Now, respective cofactors we can calculate. Cofactors are denoted by A11 is equal to minus 1 whole power 1 plus 1 into M11. Minus 1 whole power 1 plus 1 is 1, 2. So, minus 1 whole square means positive will come now. So, 1 into M11 value is 1, so 1. So, A12 minus 1 whole power 1 plus 2. Alternatively, see here plus 1 will get next to minus 1. Next to plus 1. Next to minus 1. Like this way it is. M12 equal to minus 1 into M12 value is 0. Therefore, it is 0. Next, A13 that is equal to minus 1 whole power 1 plus 3 into M13. Minus 1 whole power 4 means it is plus 1. M13 value is 0. That is equal to 0. Next, A21 minus 1 whole power 2 plus 1 M21 equal to minus 1 into M21 value is 0, that is equal to 0. Next, A22 minus 1 whole power 2 plus 2 M22. So, minus 1 whole power 4 means plus 1, M22 means 1, that is equal to 1. Next, A23 minus 1 whole power 2 plus 3 into M23. So, minus 1 into M23 value is 0, that is equal to 0. Next, A31 minus 1 whole power 3 plus 1 M31. So, minus 1 whole power 3 plus 1 means plus 1. M31 value is 0. So, anyway we will get 0. Next, A32 minus 1 whole power 3 plus 2 M32. So, minus 1 into M32 is also 0. So, 0. Next, A33 minus 1 whole power 3 plus 3 into M33. So, that is equal to minus 1 whole power plus 1 into M33 value is 1, which is equal to 1. This is the way we can calculate minus and cofactors of the elements of the given determinants. Now, we will calculate for the question number 2 in third bit. This is the last question. In this session, we are going to finish it now. Till here only, dear students. So, these are the, I will write it here. These are the minors. minus of given determinant or given det. These are the cofactors. Cofactors of given det. Given det means every element of that. Okay, we'll go to question number, last question in this session. Find minus and find minus and cofactors of the elements of the determinant, elements of the determinants. One 0 4 3 5 minus 1 0 1 2. Okay, dear students. So first, what you have to do is, first you can consider A11, A12, A13, first two elements. A21, A22, A23. Next A31, A32, A33. So first one by one, every element. First you can take first, these are the heading is minus of given determinant, given elements of the determinant, given elements of the determinant, or simply det. Here cofactors of given elements of the determinant. How we are going to do, we will see step by step here. So first element minus which are denoted by M13 equal to, that means first row third column we have to eliminate. First row, sorry, M11, no, starting. First row first column eliminate. So 5 minus 1 remaining is 5 minus 1 1 2. So 5 into 2 10, minus of minus 1 plus 1, which is equal to 11. Next M12. So first row second column eliminates. So the remaining you have to write it as data. First row second column. 3 minus 1 0 2. 3 minus 1 0 2. 3 into 2 6 minus 0, that is equal to 6. Next M13. So eliminating of first row third column, 3501 is the remaining. 3501. So 3 into 1 3 minus 0, that is equal to 3. Next M21, second row first column. So M21, second row first column. So what are the elements? 0 4 1 2, which is equal to 0 minus 4, which is equal to minus 4. Next M22, second row second column. second row, second column, 1402. 1402, which is equal to 2 minus 0, which is equal to 2. M23. So M23 means second row, third column. So 1001, which is equal to 1 minus 0, which is equal to 1. Later, M31. So minor of third row, first column. Third row, first column eliminates 0, 4, 5 minus 1. 0, 4, 5 minus 1, which is equal to 0 minus 20. Minus 20. Next, M32. Determinant of third row, second column, you have to eliminate 1, 4, 3 minus 1. 1, 4, 3 minus 1. 1 into minus 1, minus 1, minus 3 into 4, 12. So minus 13. Next, M33. Determinant of third row, third column, eliminate 1035. 1035. That is equal to 5 minus 0, which is equal to 5. So after calculating of these minus, respective cofactors we will calculate. Cofactors are denoted by capital A11. So minus 1 whole power 1 plus 1 into M11. So minus 1 whole power 1 plus 1 means plus 1 into 11. That is equal to 11. Next, A12, which is equal to minus 1 whole power 1 plus 2 into M12 minus 1 into 6, which is equal to minus 6. Next, A13, minus 1 whole power 1 plus 3 M13 equal to 1 into M13 value is 3, which is equal to 3. Next, A14, sorry, not A14, A21, which is equal to minus 1 whole power 2 plus 1 M21. So minus 1 whole power 2 plus 1 means 3, no? So minus 1 into M21 value, we got it as minus 4. So minus into minus plus 4. A22 equal to minus 1 whole power 2 plus 2 M22. So which is equal to plus 1 into M22 value is 2, which is equal to 2. Next, A23, minus 1 whole power 2 plus 3 into M23. Minus 1 whole power 2 plus 3 is minus 1 into M23 value is 1, which is equal to minus 1. Next, A31, minus 1 whole power 3 plus 1 into M31. So which is 1 into M31 value, you will get minus 20. So which is equal to minus 20. Next, A32, minus 1 whole power 3 plus 2 M32 minus 1 into M32 value is minus 13, which is equal to plus 13. A33, minus 1 whole power 3 plus 3 M33. So minus 1 whole power 3 plus 3 is 6, so it's a positive 1. Into M33 value is 5, so which is equal to 5. Therefore, these are minus and cofactors of the elements of the determinant in this. So I hope in this class, minus and cofactors of the elements of the given determinant concept and problems completed. I hope everyone understands, students. Thank you for joining this session. We will meet in the next video with adjoint and inverse of the matrices. Thank you for your support. Those who are watching first time, please like and share. It will help for not only AP Intermediate second year, but also CBSE 12th class and first year of intermediate Telangana Intermediate also. It will be helpful. Thank you, dear students. Signing off. Math Solutions by Pani.